First video about my Aquarium Controller. This is a layout of most of the parts I'm gonna use in this build. In this video I'm gonna specify about this part and the few I will need that isn't here. In a different video I will specify about the controller himself, the program, and all the features and most specifications about all the little details as the system is gonna work and why did I build it and all kind of stuff. So I'm gonna begin with this is 6 sockets. I have 2 of these for connecting all the power. I have 2 of 6 and 2 of 4. So in total I will have 18 sockets that will be controlled by the controller. I will not need all the 18 at the moment. I will have 7 that will not be at use because I wanted to have spares, so if I will want to add something later on the build, I will be able to, and we're not gonna need to start rebuilding or adding stuff. This to add it to the program, which is very simple. So that's why I did so many. For more details on the rest of the stuff, I have a fan. The fan is meant to cool the controller. The controller is based on an Arduino Mega and 2 others Arduino Uno that isn't here because they will be built later. It's gonna be not an Arduino one, but approximately the same. I have all kind of electronics here. I do not know about electronics. The programming and the electronics building is done by my brother. So I can't really explain about all these parts, but I can do partial explaining, like this switch. I have 5 of them. The cause of having these switches is that I will able to turn off every one of these. So if I don't need of them, or they're like this one, which won't gonna have anything plugged into it as a start, so it will be turned off, so it couldn't cause any problem if there is a malfunction. So this, and again, if there is any problem, I can just turn it off, so it won't gonna evolve into something big. So I can easily turn it off in case of a problem. I have some thermoresistors to check temperatures outside of the water. I have thermoresistors as well to be in. I have 3 of them to be submerged. I have voltage regulators. I have an LED screen. This will be for the control panel I'll have next to my desk, so I can see the temperature and the pH level. I have resistors and all kinds of different electronics that I can't explain to you about. I have boards for installing everything on. I have a thermal compound for connecting this one to the cooling grid, so that one gonna burn out because of the heat. where I am located, it's very hot now in the summertime, so I will need cooling for the system to keep it from burning up. I have an alarm system in case of a major problem, like more than 70% or 50% water loss. That will turn on the alarm. And I have a few other things that will turn on the alarm. I will talk about it in a different video. I will have a switch on the control panel to shut off the alarm, because if I'm not at home when the alarm is turned on, and somebody else wouldn't know what to do about it, so it's not gonna just make a lot of noise for a lot of time for nothing. So they can be able to turn it off, and they will tell me when I get home. This is also a check button for the alarm, which means if the alarm isn't turned on, I can push it to hear that it is working. That's gonna turn it on. So this will be modified. It will get power from the I don't know which one of these, but one of those parts will regulate the voltage to this one, which need a ping 3 volts, and the switch will be connected to the Arduino and to that switch. Except of that, I have a solid state relay, which will be, I have two of those, one of them for the heating and one for the cooling. On the cooling, I'm gonna do another video to explain my cooling system. I went only with two solid states because they're way more expensive than a normal relay, and a normal relay will be enough to have like a 100,000 on-off time, so till they will broke. So in all the other things, they didn't turn on and off so much, so I don't have any cause to think that they get broke fast. But this thing, the cooling, gonna turn off like 10 on off like 10-20 times a day, so I gonna need this one. I have steppers motors. This is meant for the fertilization system, for the fertilization pump. This will be the engine of the pump. The actual pump I will talk about in a different video of how we're gonna do that. I went with this choice with stepper motors because it's giving me a lot of accuracy in the fertilization, which means I'm gonna have like more accuracy than 1 milliliter of water, 1 cc, so it's gonna be very accurate. It's gonna be very good for me. I have 3 of those. One is for the anti-chlor. I don't really need one for the anti-chlor. I will talk about it in a different video. It's anti-chlorine. So, and one for I have one for normal fertilization, one for the anti-chlorine, and one for the iron fertilization. More than that, I have the pH chip. It will control the pH. I have here the pH probe, so I will know what the pH is. Because I have a planted tank, it's good to know the pH. I have a card reader that all the information will be stored on it. I'm gonna explain what information in a different video. This is a very big project, so I can't fit it all into one video. So I will do a series about it. More than that, I have power supply. I have 5 of them. It's a 2 amp power supply. I only need like 3 of those by spare. One of them for the Arduino, one for the relays, and one for LED systems that I will build to light up the inside of the cabinet, so I can see easily when I do like maintenance and cleaning the filters and stuff like that. I have an electric solenoid for the automatic water change. It's actually not a water change, it's a water fill up, so it's gonna be always filled up. In my area, I lose about 5 liters of water a day by vaporization, so it's gonna be very helpful that it will be an automatic system to fill it up. Because of this big loss of water, I have the anti-chlor injection system that I said before, so I can add anti-chlor when the water is added by that. It's gonna the controller will calculate how much I need by the water volume that will be added. I have LEDs for the controller, for the control panel, so I can know if there is a malfunction, and I have different colors. So I have a different color for everything problem, just to know if things turn on, things turn off, so it will be easily to see. I have internet socket for it's not meant for internet, it's just for the plug. All the accessories that will be connected to this will be connected with the internet plug, so it's gonna be easy to organize all the wires, because as you see, there's gonna be a lot of wires going around. So let's go back here. I have here a notebook with all the information about the controller system, all the parts list, all the things that it's gonna do, all the features. I have here the Batman box, because, well, you can't do it without the Batman. So the main purpose of this box is because it's metal. It will reduce noise, the electricity noise, and therefore will have less problem with the controller being disrupted because the electromagnetic noise. This will absorb it and prevent it to getting to the controller himself, and therefore causing less problems. This is my tablet. It's a 7-inch tablet. I bought it for this project. The whole controller will be controlled by an Android program that I did the graphics side of it, and my brother did the programming. It will be controlled from him. I will show you the program in a different video. There is a problem with the tablet. It was very cheap and, well, not very good. This is so I have still some parts that isn't here, like the relay and stuff. I have 9 packages still on the way. I will show you the other parts in the different video. So that's more everything here, and I will do a few more videos to clarify all this other stuff. So I hope you enjoyed.